Ooh. Alright, hello everyone. It's April the 1st. Alright. Didn't do this yesterday, so I'll have to do it really fast today. Oh, it's an easy problem. Thank goodness. Ooh, what happened? Here we go. The length of the last word. Given a string, S consists of words and space. Return the length of the last word. Okay, the Java has functions to handle this. Well, we can check. Java split string by delimiter. Does it have? Ooh, I think it does. It's called split. I think I just call split. Alright, this one I have to check. I actually don't know. Split, what's the behavior of a split? Right? We don't know this behavior. So if we say a equal to, actually we can just use this. This is a good example. Okay. What does split do? Okay, so string s equal to a dot split. Can we just do this? Is it working? Okay, has to be a string. Okay, and then we go, so you see the white space at the end gets escaped. So we just check the last one. Okay, so that shall work. Okay, so we're gonna say a string, right? And split it. S dot split have to be a string, and what if it's empty, consists of only at least one wording? Okay, so we can just return split it dot split it dot length -1 dot size. Right, is it size or length? Maybe it's length. I think it's probably length. Okay, yeah. All right, it's not bad. That was not bad. Length, 58. Okay. So we're done with this. Back to this one. So I think I was thinking about it last night, and we can redo the DP relations. So here's what the DP is gonna do. The DP is number of digits. Okay, number of digits. Now we always try to find the first digit, right? The number of digits, number of odd. Okay, so number of odd that's required. And does it have an upper bound? Right, is bounded. Is bounded. If it's not bounded, we just go all the way up to 0 to 9. If it's bounded, we have to check, right? It's bounded. And we forgot one thing, which is the required remainder, right? So it just has to be a remainder, right? What is the remainder that it has to be for the current thing, right? So I think that this is what's needed. So what's needed for this current digit, right? The current number, right? The current number to divided by k. So when we start, let's say if we want k equal to 7, right? And we want to find all the 4-digit numbers start with 1. So we can say dp, number of digits is 4, right? Number of odd need to be 2. Is bounded is false, right? Wait, hold a second. Actually, no. That's not true, because I'll do with 1, right? The current is 1. If the current is 1, so we have 1 something something something. So from there, what I will call, so this one will call dp 3 digits, right? Number of odd, because I use 1, so number of odd is 1. I'm going to have 1 odd. Is bounded. Well, in this case, it's not bounded because I'm going to go everything. So it's false, not bounded. Now the remainder. So we're taking 1,000 out, right? And the answer should be, so this one should be 0, right? But we take 1,000 out. So this should be 0 minus 1,000 mod 7, right? And then we need to plus 7. And then mod 7. I think that's what it needs to be. And 1,000 mod 7 is... Oh, actually, I'm not quite sure. 1,000 mod 7. Is 6. Right? So this one is 6. So this whole thing is 1. So we are doing dp 3, 1, false, and 1. So we need to find a 3-digit number, which mod 7 become 1, right? So we'll do this. So because this and it's false, so we can go from 0, right? We can go 0 dot dot 1 dot dot 2 dot 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 equal to 9 dot dot. So for 0 dot dot, what we're gonna do is dp2, right? Because I get even, so we still do 1. We still have 1 left, and again it's false because previous is false. Then the current is always false, right? Because it's not bounded. And now it's a 0, so we need still gonna be 1, right? And then 1, we can call it dp on the 2, but here is not 1 anymore because I did 2, so we have a 0, right? And then again, it's going to be false, and this is 100, so we're going to do 0. Okay, not 0 actually, because it's what is required. Required is 1, so it should be 1 minus 100 mod 7 plus 7, and this thing mod 7. because we want this number to mod 1. So we need this number to mod something like that, right? And then we go the same thing. Let's put something together. Okay, so if we want to test this, we have to put something to 2827. Okay, do we have 2827? I think it doesn't matter. We just need to 2827. Okay. Func tools, LRU cache, sure. Alright, so what do we do here? Low, high, and then k, right? So what we need to do is we need to define a function. Define a function called dp, number of digit, number of odd, is bounded, it's a Boolean value, and remainder, and this one will return an integer. Okay, number of digits, number of odds is bounded, whether we can for the current, right, for the current digit, whether we can go all the way to 9 are the target remainder to reach the current number. Okay, so well, and if number of digits is equal to 1, right? If we only have 1 digit, then if we want to have 1 digit, depends on what r is, right? For a number of digit, and then we have the target r. Since r is the only one we can return, because other than r, you actually, that's not true. That's not true. So what we need to do is I think what we return is this. If number of digit is 0, right? If number of digit is 0, what we need to find is if r is equal to 0, right? If r is equal to 0, then it's perfect, we're done, right? If r is equal to 0, then we are done. If r is not equal to 0, then it's bad. So if this is equal to 0, we shall return int r is equal to 0. If r equal to 0 is true, then we have found one. Otherwise, we don't. Okay. All right. Otherwise, if nd is not equal to 0, then what we need to do is to check if it's bounded. So max allowed. So max allowed is equal to 9. Okay. Then we need to see if it's bounded. If it's bounded, then we have to go to probably need high and is bounded and high bound. High bound. The max number allowed we use this, right? We use this to high bound string. Okay, so we use this to check, to determine the bound for each digit, for a digit, if applicable, right? So if it's bound, then max allowed, because we have a number of digit, right? So it would be -1, -2, -3. Max allowed shall equal to integer high bound this minus number of digit. That's the high bound. Then what we can say is for current digit in range from 0 all the way to max allowed plus 1. Right? For D in range, max allowed. Now for each D, we also need a rest is equal to 0, right? So for each digit, we're going to check, right, if we have, okay, actually we can do this. If number of this is smaller than 0, it should turn 0, right? Then if this is equal to 0, right, and then we shall return and number of this equal to 0, both need to be 0, right? Because if one of them is not 0, that's bad. Number of odd need to be 0 and r need to be 0. Okay. Okay, now here we can just do dp, right? Number of digit -1, number of odd, or minus digit mod 2 is bound would be followed by the previous. So the previous is not bounded, then the current one doesn't have to be bounded, right? Oh, it depends. It depends. If previous is not bounded, then definitely it's not going to be bounded. So if previous is false, then it's going to be false. If previous is true, is bounded, then D shall equal to max allowed, right? If previous is not bounded, then the current is also not bounded. If previous is bounded, then the current will be bounded if we go all the way to the maximum. If it's not maximum, it's also not bounded. So it will be that. Then remainder. So the remainder will be, if we check this formula, so the required remainder, right, r minus d times 10 to the power of number of digit. Is that true? 3 digits? No, actually minus, I think we can do this. Number of digit -1, right? This one mod k. Alright, what's this? This next remainder shall equal to r minus, okay, d times 110, not this one, -1, whole thing mod k, and the whole thing plus k, and the whole thing mod k. just in case we have like a negative situation. Okay, so here we can say this next R and high bound str. I mean, we don't need to do this, the high bound str. I think we don't need to put it here because what we can do, you know what? I take it back. I think it's necessary to put high bound str, so taking it back. I want to do high bound str. I think it's necessary, right? So dp is this, which we will say rest plus equal to the dp. And then we'll check the next one, check the next one, check the next one until when we're done, and then we'll return rest. Okay. All right. So we want to find the total number, right, up into high, because we have a high count, right? So we have a high count. Then what we're gonna do is for D in range from 1 all the way to high count, high str equal to str high, right, to int high str 0, right? That's the first one, and plus 1. This is what we are allowed. And then we say high count plus equal to dp. Number of digits, which is len high str, right, minus 1. Number of digits, number of odd, number of, oh, hold a second. It depends on how many digits this current one has. Yeah, it depends on what the highest TR are. What does it have? Okay, so there's so this is the DP. Okay, we have to handle DP first. This is value cache. Max size is none. Okay. Then we need another function. Okay, we need another function called def count. Okay. Then what we're gonna say is the high bound. We're gonna pass an integer to it, and then we're gonna do this. So now it depends on the high bound, what the high bound is, right? So the high bound could be number of digits, right? The number of digits. If it's a odd number of digits, then we know it cannot be. So I have to drop down, right? Have to drop down. So we shall say if that's a high bound str shall equal to str high bound. Okay. Now we say if len high bound str, if this mod 2 is equal to 0, is not equal to 0, okay, if it's not equal to 0, then high bound str shall equal to basically 9 times len high bound str minus 1, right? Then this is our new high bound high bound is going to be, it has to be even numbers, right? Even numbers. And then what we're going to do is it's going to be all false. So we're just going to go through the whole thing. Actually, I don't even need a high bound str, right? We don't need a high bound str because everything's going to be all the way to 999, right? 999. So what we can say is, hold on, let me do a rest here. Then we just for, right? For digit in range all the way to 10. Everything is fair game. So we can say rest plus equal to tp len high bound this, okay, and well, actually -2 because I have the d right now, right? -2. Then number of odd minus d, the 2, that's good. Is bound is always false because it's not bounded, and we'll find the next r. Okay, so we need to do the next r. So next remainder shall be 0 minus digit, right, times 10 to the let me do one more thing. So number of digit shall equal to len high bound str minus 1. Number of digit, yes, that's the number of digit for the current, right? So current, probably should say current. So current number of digits is going to be this, and here is going to be current number of digits minus 1, and this is going to be again current number of digits minus 1, right? So current digit times this, 0 minus this, okay, and we'll mod k, plus k and then mod k. Right, so 0 minus this, hold a second, d times this. We should mod k here first, right? Yeah, hold on. All right, I have to drop off really soon. Right, so this one mod k, 0 minus this mod k plus k, and then we mod k. Right, so that's the next r, and next r, and this is just a string, it doesn't matter. Okay, we just go through this, every single one, go through. That's if else. Okay, so else is to be continued. All right, to be continued. All right, so that'll be this. I'll come back to this later today. All right, that'll be it. I'll see you guys later. Adios.